Namaskar friends. Hello, how are you? I hope you are doing well. Myself Dr. Ashwini Kumar Gupta. Today I'll be taking you the second lecture of our series Basic Organic Chemistry. As you know, in the past lecture I had taken you very basic 9th and 10th chemistry, in which I had taught you what is catenation, what is tetravalency, what are the different types of structures, the dot structure, the dash structure, then different type of carbon atoms, hydrogen atoms, and a little bit of I had given an overview of functional groups. Not in detail, although not in detail, but initial part I had started it. So I'll just take a slight revision of that particular functional group today. I will start with. Now, as I told, basically what do you mean by a functional group? Functional group actually is what? It is a substituent. It is a substituent, or you can say a moiety which is attached to the molecule, thus leading to a chemical reactivity, different chemical reactions. Now, as I had told you in the previous lecture, why does this chemical reaction occur? A simple fact: since there is a shifting of electrons from one atom to other, that means either one atom will pull electrons towards each other, or the other atom will donate electrons towards other. And this particular this particular function is more prominent due to the presence of functional group. So you can say, due to the presence of functional group, you can have different chemical reactions. I will take you a simple example. Suppose this is CH3 and some functional group X. In general, I am taking functional group, G. I beg your pardon, CH3G. Now, CH3G, that means suppose the parent happens to be CH4, one H of this CH4 is replaced by CH3G, right? Suppose this G is nothing else but a functional group. Now, this G might be either electron withdrawing or donating. Electron withdrawing or electron donating. Thus, what happens? There is a movement or transfer of electrons. Now, and due to this, leading to a different chemical reaction. Right? Now, if I want to sum up, suppose, what do you mean by functional group? Now I can say a functional group is nothing else but a group of atoms. Which, when attached to a particular molecule, results in shifting of electrons from one atom to other, or one molecule to other, thus leading to the formation of different chemical reactions. Now, right, I think so you might have understood now. Now I'll give you a few more explanation on this now. Now, a functional group, suppose this is CH3G, same way, and just now assume that this G, which is a functional group, is a electron withdrawing, I'm writing in a short form, W, withdrawing group. It is a electron withdrawing group. Now, in CH3G, that means if it is an electron withdrawing group, the electrons will flow along the bond towards it. And similarly, if suppose if it is CH3, CH2 and the same functional group is attached, although the functional group of G, which is here or here, same functional group, the function in both the cases happens to be same. That means this functional group, the same which is attached here, the function of the functional group in both the scenario, in both the type of molecule happens to be same, right? Although the reactivity might decrease due to the presence of, just we have seen one CH3, but one extra CH2 has come. So it might affect the rate of reaction. It might affect the rate of the reaction. Affect rate of reaction, I can say, right? But in all, the function will remain the same. The function of this particular functional group will remain the same, irrespective whether it is here or in here. Now, so you can say, suppose, one more example I'll take you. Suppose this is CH3, CH, take it, suppose some another functional group, and here this is another, this is our G, normal, which that is electron withdrawing group, right? So this is also some of the functional group, this is also one functional group, this is also one functional group. Now the presence of this functional group, both the functional group, the function of the individual functional group will remain the same. For example, G, as I told you that it will be electron withdrawing group, and presuming X also is an electron donating group. Why? Right? Suppose X is a electron donating group and G is a electron withdrawing group. Now, the function of the two, G here, here and here, all the three are same. But due to its close proximity, that means X functional group is near to G, the presence of X can affect the chemical reactivity pattern of this particular molecule. That means X, which is an electron donating group, as I have told you, since it will be pumping electrons, since X will be pumping electrons and this G will be pulling out electrons. So since it will be pumping electrons, so here the electron density will be more. It will be increasing. Similarly, since this group is the electron withdrawing group, so here the density of electron is so much that more the amount of electrons are getting attracted, withdrawn by this particular G. Similarly, if this X is not present, if it is simple CH3, CH2 and then G, although here also it is an electron withdrawing, but the absence of X will slightly affect the withdrawing power of G, right? Because there is no extra electron density, right? Therefore, now I hope you have understood. Thus, can I say, what do you mean by functional group? They are specific atoms. Functional group, they are specific group of atoms. They are specific group of atoms which when bonded, to a particular molecule, gives certain physical as well as chemical properties. Chemical properties. Properties to that particular molecule. Now, as we have seen here, take for example CH3, CH2, take for example CH2 and G. G is our functional group, right? Now, the carbon atom which is bonded, the first carbon, this is the first carbon, this is the second carbon, can I say this is the third carbon? So the first carbon which is directly bonded to G, that means the carbon atom directly bonded to the functional group is known as alpha carbon atom. This second, it is known as beta carbon atom. That means the second carbon atom which is bonded to the functional group is known as beta carbon atom, and the third carbon atom which is bonded to the functional group, this is the first, this is the second, and this is the third, so this is known as gamma. Your gamma, alpha, beta, gamma carbon atom. That means the depending upon its position from the functional group, depending upon the position from the functional group, these three names are given, right? Now, you can take this now. Suppose similarly CH3, CH2 and G. Similarly, as we have told that this is alpha, this is beta. Similarly, a functional group which is attached to just one carbon atom. The G functional group is attached directly to one carbon atom. So it will be known as primary functional group. Fine. Similarly, CH3, suppose CH2, this is G. This is bonded to some other carbon atom. Now this is bonded to two carbon atom, this and this. So this is known as secondary secondary functional group. Similarly, CH3, CH2, our G, this is bonded to CH3. Here it is bonded to another CH3. So can I say it is bonded to 1, 2 and 3 carbon atoms directly? So it is a tertiary functional group. Primary, secondary and tertiary functional group. Although all the three are this carbon, this carbon, this carbon and this carbon, they all are directly bonded to the function. So this is also alpha, this is also alpha carbon atom and this is also alpha carbon atom. Fine. Okay. So in all, now we'll see some few functional group examples. Examples of functional group. These functional group have prefix name and suffix. Prefix matlab previously, first, and suffix. Prefix and suffix name. To be more elaborate, we will about this prefix and suffix we will see in a further lecture, further topic basically. But at this juncture, you just remember the prefix and the suffix name. Okay? Now we'll take certain examples. Most of the functional group, you can say, are besides this C double bond O, C double bond O and C. This is known as carbonyl group. Fine. Carbonyl group. I will give you a few examples. Now this side means this side will be some R, sorry, some R, then C, double bond O, then depends, whatever. It can be different values. Now we will see some few examples. Okay. Now we will see, suppose this is R, this is C, double bond O, and suppose OH is written. That means I can say COOH. COOH. This is the structure form. The name of this particular thing is known as carboxylic acid. Right? Now, for carboxylic acid, its prefix is called as carboxy. Prefix. Henceforth, I will write as P and S. Right? Prefix carboxylic acid is known as P. This, and for suffix it is known as either OIC acid or carboxylic acid. The name itself can be carboxylic acid or oic acid, which is suffix. Fine. Carboxylic acid, RCOOH, right? Carboxylic acid, the name of this, COOH. Its prefix is carboxy and suffix is OIC acid. As I have told you, you just first you try to remember what do you mean by prefix and suffix. The name of prefix and suffix. The more elaborate part we will see in the next part, further parts. Fine. Now coming to similarly R, C, double bond O. Fine. Here it was OH. Now here O. Instead of H, C, double bond O. R. Right? R, C, double bond O. This is known as carboxylic anhydride. Right? Carboxylic anhydride. Anhydride. Now, it has no prefix. There is no prefix for carboxylic anhydride. And the suffix happens to be OIC anhydride. Sorry. OIC anhydride. It has no prefix. Remember, or it is also known as carboxylic anhydride. Hydride. Fine? Okay? Okay. Now, RC double bond O. RC. You can see this part remains the same. Here, and similarly RC double bond O, R dash, or RC double bond O, R. This is some carbon atom, and similarly here is the other carbon. We can also write as COOR. Right? Here again this part remains same. This particular part. As I told you that carbonyl is the, you can say, is the basis of most of the many functional groups, C double bond O. Now, what is this known as? Thus, prefix of this is known as alkoxycarbonyl. 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 And the Suffix is OATE, O8, or also carboxylate, OATE or carboxylate. This is the suffix. This is the suffix. Fine. Alkoxycarbodyl. It is known as it is the prefix. Fine. Okay. Now we will go to RC double bond OCl, which is also you can write as COCl. Right? This is known as acid halide. Acid halide. Just look the previous slide also every now and then, so that the flow should be continued for all the functional group. You just try to see it. Fine. Now acid halide. The prefix now. Prefix is known as halocarbonyl, which is the prefix. Halocarbonyl. Halocarbonyl. And now OYL. OYL halide. OYL halide. OYL halide. Right? Now, or else it is also known as carbonyl halide. Carbonyl halide. This is nothing else but the suffix part. This is the suffix part. Fine. Now, we'll see amide. AMIDE, amide, which is RC double bond O NH2. RC double bond O NH2. It's also written as CONH2. CONH2. Okay? Now, amides. Now, what will be the prefix for it? It is known as carbamyl. Carbamoyl. MOYL. Carbamoyl. And this will be the prefix. And the suffix happens to be amide or carboxamide. Carboxamide. Amide or carboxamide. This is the suffix. Fine. Amide RCONH2, known as carbamoyl, is prefix, and amide or carboxamide is the suffix. Fine. Now, oh sorry, it's getting something. Now, this are, see, now here some different type. There is no carbonyl. This is RC triple bond N, which is known as nitrile. It is known as nitrile. It's also written as CN. RC triple bond N, which is nitrile. Nitrile. The prefix is CYANO, cyano, which is the prefix. Fine. And nitrile or carboxyl Nitrile. Nitrile or carbonitrile is for the suffix part. Fine? Absolutely fine. Okay. Now, another thing. Again, RC double bond O. Again, this RC double bond O has come, as in case of, up till now we had, let's see. Sorry. RC double bond O H. RC double bond OH, which is written as CHO. RC double bond OH, which is CHO. Now, formyl. 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 Formyl, which is the prefix. Which is the prefix, formyl, and suffix happens to be al, or carbaldehyde. Carbaldehyde. This is the suffix. Al or carbaldehyde. Carbaldehyde. Fine? Now, another. This again, RC double bond O and R. That means two carbons here. Between the two carbons, one carbonyl is situated. RC double bond O. RC double bond O. You can also write as double bond O. C double bond O. This is known as ketone. Ketone. Fine? This is known as ketone. The prefix happens to be oxo. Oxo is known as the prefix, and ketone. Prefix happens to be oxo, and the suffix happens to be ol. Happens to be ol. The prefix happens to be oxo, suffix happens to be ol. Right? Just take a note on this, everything. Fine? Formyl. Fine? Okay? Okay. Now we will carry forward to other more functional groups. Okay? Now, alcohol, which is denoted by OH, or you can say ROH, alcohol. Alcohols here. Now, the prefix happens to be hydroxy. Happens to be the prefix. Fine? And the suffix happens to be ol. This happens to be the suffix. As in case of aldehyde, if you see the previous slide, in that we had the suffix happens to be for aldehyde was al. For ketone, it was ol. Similarly, for alcohol, it is ol. Fine? Now, there is something called phenol. Phenol. Now, phenol is nothing else but aromatic ring attached to an OH. Suppose, as we have seen for alkyl groups we denoted by R. So phenols are denoted by, they are aromatic. aromatic, because they give a nice aroma, nice smell. So aromatic, so AR. So I will say phenols are nothing but AROH. More in detail about aromatic we will see in the further lectures. But at this juncture you just see कि any 6-membered ring, cyclic ring, 6-membered. If you have seen in the previous slide, I had told you, in the previous lecture, double bond, single bond, another double bond, another single bond, another double bond. So such type of compounds, this is benzene, as I have told you. Benzene, in the classification of compounds I have told, aromatic is one of the classification. Aromatic, benzenes, double bond, single bond, double bond, single. That means I will say it is a conjugated means double, single. So it is known as aromatic. So at this point you just try to understand aromatic when attached to OH is known as phenol, and its prefix happens to be again the same thing, hydroxy is the prefix, and the suffix again happens to be all, same thing, no change. Suffix happens to be all similarly. Now this okay, just may try to divide it. Fine. Now there is something called thiol, which happens to be R-SH. What is this S? This is sulfur, thiol, right? Now for thiol the prefix happens to be mercapto. Mercapto happens to be the prefix. Mercapto happens to be the prefix, and thiol, THIOL, happens to be the suffix. Thiol, prefix and suffix. Suffix happens to be thiol, and mercapto happens to be the prefix. Now another we will see amines. AMINES. Amines is nothing else but R, which is bonded to NH2. R bonded to NH2. The prefix happens to be amino. Amino is the prefix for NH2. Amino is the prefix for NH2, and amine happens to be the suffix, amine. Fine. Now another one, you can say imine. Imine is nothing else but when R double bonded to NH. That means you can say C double bond N. C double bond N. Right? C double bond, to be more precise, C double bond NH. So C double bond NH is known as imine. Imine. The prefix happens to be imino. Imino is the prefix, and the suffix happens to be imine. Imine happens to be the suffix. This is imino is the prefix. Fine. Sulfonic acid. Sulfonic acid, which is SO3H. That means this is bonded to R. SO3H is known as sulfonic acid. Sulfonic acid. The prefix happens to be sulfo. Sulfo happens to be the prefix, and Sulfonic happens to be the suffix. Sulfonic acid happens to be the suffix. Sulfo is known as the prefix and sulfonic acid happens to be the suffix. Fine. Order of functional groups. Order of functional groups. Fine. Means I will say functional which the functional group are either very strong functional group and weak functional groups. Strong functional groups matlab those functional groups who are highly electron withdrawing group. The electron withdrawing part comes initially, first part, initial, and then as we go down the order, that means suppose I'll give you an example. Now suppose this is COOH, which is carboxylic acid. This is preferred more electronegative. You can say SO3H. Fine. Then comes anhydride. Then comes ester. Ester in the sense COOR. You can say anhydride was C double bond O. C double bond O, anhydride, then ester, then COCl. Fine. Then comes CONH2. Then comes CN. Then comes CHO. Then comes, can say, ketone, C double bond O. Remember, RR, ketone. Then comes OH, that means alcohol or OH. Then comes, you can say, phenol. If you remember, aromatic AR bonded to OH is phenol. Then comes SH. Fine. Thiol. Then comes NH2. Fine. Then comes imine. Imine means C double bond NH. Fine. Now then comes C double bond C. This is also one of the functional group. That means alkenes. Alkenes are also functional groups because double bond, that means these double bonds are nothing else but rich in electrons. They are rich in electrons. Electron rich moieties they are. Electron rich group of atoms, you can say. Electron rich. Then comes C triple bond C. Fine. That means this is alkene. This is alkyne. And lastly comes C single bond C. C double bond C, C triple bond C, and this is C single bond C. That means alkane, I can say. If you remember, I had told you double bond, triple bond is known as unsaturated. Fine. And this is saturated. Unsaturated double bond comes first, unsaturated triple bond, then our saturated alkane comes. This is the particular order. So you try to make a point now. See, this R, or you can say aromatic phenyl, it is also known as phenyl, aromatic, right? Phenyl. Then you can say halogen. It is also one of the functional group, as I told you, COCl, right? Halogen, which can be chlorine, bromine, iodine, whatever. Halogen. Then you can say NO2, which is known as nitro, which is known as nitro. Then another one is OR. What? OR. OR. This is known as alkoxy. Known as alkoxy. Why have I written this? This is nothing else but alkyl. This is nothing else but aromatic. This is halogen, chlorine, bromine, iodine, etc. Then nitro. NO2 is known as nitro. OR is known as alkoxy. These are nothing else but substituent. Substituent. That means a substituent will be always referred in terms of prefix only. It will not have any suffix. It will always have only and only prefix, nothing else. Fine? Okay? Alkyl, aromatic, halogen, nitro, OR, alkoxy. Okay? Okay. Now shall we move next? Electronegativity. It is also known as EN. It is represented many times. Electronegativity. Electronegativity. But what do you mean by electronegativity? Now, as I told in the previous slide, I have told you there are functional groups who are electron withdrawing groups. They are electron. They pull electron towards itself. If they pull electron towards itself, means it will become rich in electrons. Take for example, this is some electronegative element. Okay, it will pull electron, so it will become rich in electrons, and this will be deficient in electrons. So always rich in electrons is indicated by a negative sign. You can say like that, negative sign, and a loss. The constituent or the carbon atom which loses, or the element basically which loses electron, is denoted by positive charge. This is denoted by negative charge. This is denoted by positive charge. What does this negative sign indicate? That it is rich in electron. This is rich in electrons, and this is electron deficient. You can say, electron deficient, or shortage of electrons. Shortage of electrons. Fine. Now, the tendency, you can say, of groups or functional groups to attract electrons. The tendency of functional group to attract electron is nothing else but electronegativity. Negativity. Electronegativity, and the elements who do it, or the functional group or a particular element. There are elements also and a group of atoms. You can say functional group. For example, I'll give you an example. Take for example electronegativity. The functional group happens, take for example COOH, that is carboxylic acid. They are electronegative elements, or they show electronegativity. Fine. Similarly, I can say halogens like fluorine, chlorine. They are also electronegative elements. These are electronegative groups. These are electronegative group. This is electronegative element. Fine. So this tendency is known as electronegativity. Negativity has to be measured. Means how will I come to know which element or which group is more electronegative? Now we will, as in class 9th and class 10th, we have read about periodic table. Fine. Periodic table in class 9, class 10th we have seen. Periodic table. Fine. Now, in periodic table there are elements, and each element have their own specific value of electronegative, and this value should have some precise or some digital value, means numerical value, so that I will come to know this element is more electronegative than this element. That means X is more electronegative than Y. But how will I come to know X is more negative? By some of the other numerical value. Now the scale happens from 0 to 4. 0 being the least electronegative, and 4 being the most electronegative. Fine. Most electronegative and least electronegative. Seen in the periodic table, extreme left of periodic table, I will write it as PT. Left of periodic table are group 1 and group 2. Group 1 and group 2, that is alkali metal, and alkaline earth metal. That means metals are present in group 1 and group 2. Group 1 and group 2. Now, these metals are known as electropositive. Metals are electropositive in nature. That means, what do you mean by electropositive? Means electron donating. Now, we have to see why metals are electropositive in nature. I'll write as electropositive, plus and V, positive. Fine. Electropositive, that means electron donating. Why? Now, as we know, each and every element have some specific atomic radii. What do you mean by atomic radii? This is the atomic radii, this is the nucleus, and these are the shell. Fine, these are the shell. Right? Now, in the periodic table from left to right, the atomic radii continuously decreases. That means group 1 and group 2 have the maximum atomic radii. Atomic radii means atomic radius means distance between nucleus and the valence shell. Valence shell means last shell. Atomic radius is nothing else but distance between the nucleus and the valence shell. That means from here to here. Right? Now the group 1 and group 2 have the, suppose this is group 1, and then group 2 will be slightly small. As I go from here, it will become smaller. Fine? From left to right. Fine? Now, as the distance in group 1 and group 2, it is maximum from here to here. Fine? Thus, the force of attraction between the nucleus and the valence electron is the least. Force of attraction between nucleus and the valence shell is least in metals. Why? Because they have a very large atomic radii. Atomic radii or radius. Right? If the force of attraction is weak, then obviously the electrons which are revolving around can be easily thrown off. Means it will have no attraction. The nucleus will be not so powerful to hold the electron towards itself, so it can be easily removed. So the valence electron can be easily removed. So there is, basically you can say, there is a flow of electrons throughout the metals. That is why a metal, when a electric current is passed through a metal, it's a good conductor of heat and electricity, metals. But wood is not a heat and electricity, good metal, wood is not a good conductor of heat and electricity, but metals are very good conductors of heat and electricity. That is why copper metal is used for passing of electric current. Fine. Now, so I can say, since electrons are easily removed from the valence shell, that means there is a loss of electron. That means, can I say it is electron donating? Electron donating. So that means I can say they are electropositive. So these guys are, metals are electropositive in nature. Suppose, as we have seen, suppose for example I will take period second period. There is carbon F. That means carbon, nitrogen, oxygen, fluorine. Right? The atomic radii decreases, means it is least in fluorine, most in carbon. Clear? Now, so the electron donating effect, या फिर electropositivity of carbon will be more as compared to fluorine. Fluorine will be highly electronegative. It will not leave electron because it has a very small atomic radius. It has a very small atomic radius. Obviously, then the distance between nucleus and the valence shell will be very strong. The force of attraction will be very strong. Obviously, if the force of attraction is strong, then the valence electron will easily left out. Right? Then there will be no flow of electrons. That means, since the distance is very small, therefore it is electronegative in nature. That means, can I say from left to right, electronegativity increases, left to right electronegativity increases. Similarly, from left to right, electropositivity decreases. Electropositivity decreases. Fine. Now, so can we say now functional groups can be either electropositive or electronegative? Electropositive or electronegative? Fine. Now, since the functional groups are electropositive and electronegative, that means there will be a flow of electrons from one atom to other. There will be a flow of electrons from one atom to other. That means throughout in the molecule there will be a flow of electrons. Fine. Due to this nature, there will be a flow of electrons, and this will lead to chemical reactivity. So I hope now you have understood. Fine. And this reaction takes place and products are formed. Yeah. Now, as we know, in chemical reaction, bonds are broken and new bonds are formed. Bonds are formed. Fine. Now, this breaking of bonds, take for example, this is R, this is G. Now we'll take two cases. This breaking of bond, suppose if I say, now in one case we will see if G is electronegative. That means electron withdrawing. It will pull, attract electron. It will withdraw electrons. It will attract electrons. Fine. Now, so what will happen? The electrons will go from here to here. So can I say here the electrons will be going from here to here every now and then? So this will be rich in electrons, so it will be minus charge, and this will be positive charge. Right? Now, due to this, what will happen? The bond breaks. It will form R positive, G negative. Okay? R positive and G negative due to the flow of electrons. And this R positive is known as carbocation. Take for example, I'll give you. Suppose CH3COOH. It is electron withdrawing. Fine. This is a functional group. In this case, some CH3 plus is going to form, which is carbocation. Right? There are many other ways by which carbocation is formed. First, we will see just superficial, just we'll try to understand what you mean by carbocation. The actual process we'll see later on. Okay? So this is carbocation. At this juncture, you try to understand. That means a flow of electron is there means complete flow of electron from one end to the other. Okay? Now similarly in the second case, if G is electropositive, that means electron donating group. Donating R. That means it will donate. Fine. It will donate. So this will become rich in electrons. So now we'll see it will form R minus plus G. And this is known as carbon ion. Fine. This will be known as carbon ion. This is known as carbocation. So you can say the breaking of this bond leads to the formation of carbocation, and this is leads to the form of this leads to the formation of carbon ion, right? So such type of breaking is known as heterolytic cleavage or heterolytic fission. Suppose R is there and G is there. In the third case, it so happens that there is a breaking of bond when these particular fragments leave each other. They go apart from each other. Then this G takes away its electron which it had given for during the formation of it has taken its electron, and this he will take its own. If you have seen up till now, we were seeing like that. But in this case, it is like just single-headed. Single-headed means a single electron, because we know for formation of a bond we require two electrons. When these two share the electron, then a bond is formed. But when this bond breaks, what happens? This electron stays with one fragment, this electron stays with the other fragment. Thus, this is a electron without pair. That means it is an unpaired electron. Unpaired electron. Right? This and this. So I can say this is like that. Plus. Right? These things are known as free radical. Free radical is what? When R fragment with a single unpaired electron, this fragment with a single electron. This is known as free radical. And such type of breaking is known as homolytic fission. Homolytic fission. Okay. I hope you might have understood what I have taught. So just please try to correlate the lecture first with the lecture 2 second. And then today's lecture you will be able to understand very nicely. So it's sufficient for this lecture now. So I will be taking a leave, and I'll just request you to kindly give comments. Write in the comments what part, what topic, what point you are unable to understand it, so that I can clear your doubts. And I do request you that please do like my video, share it, and please subscribe my channel. Thank you. Thanks a lot.